Okay, geometry, we're going to do a quick lesson on symmetry. It's section 5 of chapter 3. There's a couple of different ways to think about symmetry. Line symmetry means that you can, like, let me show you something that's symmetrical. The letter T is symmetrical. Line symmetry means that you can draw a line through it and that it can be kind of mapped onto itself. So in other words, this left half, if I reflect that across the line of symmetry, this is called, then it would match up with the other half. Okay? If you think about a starfish has what's called pentaradial symmetry. Penta means 5, of course, and radial means it goes through the middle, the radius, or through the center. So if I drew a line here, you could map that onto itself. Okay, you could fold it over. I could draw a line here, I could draw a line here, I could draw a line here, and lastly, I could draw a line there. And all 5 of those ways, I could fold that starfish over and it would match onto itself. Okay? The other kind of symmetry is called rotational symmetry. And rotational symmetry, it simply means that you're going to, instead of reflecting it, you are going to rotate it. Okay? So I'm looking on page 260 and they talk about this. So let's just take an easy one. Let's take a square. Okay? The center of symmetry for this one would be right there in the middle. Usually you can find the center of symmetry by going to the opposite vertexes, drawing a line there, drawing a line there. There's going to be your center of symmetry. Now, if you think about this square, if I rotate it, let's say 45 degrees, so then it would look kind of like this. Does this make sense? That has not mapped onto itself yet, so I need to rotate it further. If I rotate it 90 degrees, if I had a square that started like that, and I rotate it 90 degrees, do you see it's going to match up with itself again? Okay? So let's keep track of that. 90 degrees. Of course, I could rotate it. So look at my hand. If I rotate it 90 and then I rotate it 180, that would also match up. I can't do this with my hand. Here, here, here. 270 would also match up. If I rotate this all the way around, I come back to where I began. So either you could think of that as 0 degrees, or I guess we could think of it as 360. You're not going to count it twice. There's a thing called the order of symmetry. The order of symmetry is just how many times you can, as you rotate it, is it going to match up with itself in between 0 and 1 whole turn. Okay? So it matches up with itself now, at 90, at 180, and at 270. So this one has an order of 4. And there is something called a magnitude of symmetry. Magnitude of symmetry is simply, what do they say? It's the smallest angle through which a figure can be rotated that it maps onto itself. And you can look at our figure here and you can figure that out. The smallest angle you can rotate it through is 90 degrees. But there's a little more mathematical way to do that. You could say that the magnitude, can you see this? Yes, you can. The magnitude equals 360 divided by the order. Okay? So in this case, the magnitude would be 90 degrees. Think about if I had a hexagon. Well, you can look at that and you can see, okay, if I rotate it 45 degrees, it's not going to be quite right. But if I rotate it 60 degrees, it would map onto itself. So in this case, you can look at it and you can get 60 degrees, 120 degrees, 180 degrees, 240 degrees, 300 degrees, and then you would be back to your start, 360. So you can do 2, 4, 6. It has an order of 6 and a magnitude of 360 divided by 6. So a magnitude of 60 degrees. Okay, I think that's about it. They're going to give you a lot of examples, but that is all in this chapter.